Logarithms and logarithmic functions, part 2. Example 5, using inverse properties. All right, so by definition of logarithm, it follows that our logarithmic function g of x equals log base b of x is the inverse of the exponential function f of x equals b to the x power. This means, this is your composition function, remember, g of f of x equals log base b of b to the x power. So if you substitute the f function into g, you get log base b of b equals raised to the x power. So this cancels and leaves just x. It also follows, if you switch the order, if you do f of g of x, so that is your exponential function with your log base b put into that function. So base b raised to the log base b of x equals x as well. Again, the b and the log b cancel and leave just x. So in other words, exponential functions and logarithmic functions undo each other. Okay, so they are inverses, they kind of undo each other. So if you look at a part, you've got 10 to the log 4. Remember, log, when there's no base, it's assumed to be base 10. So again, log, here's the exponential part, b raised to the log b cancels and leaves x. So that means this one's going to be just 4. All right, because again, that can be rewritten as 10 log base 10 of 4. All right, so that equals 4. B part says log base 5 of 25 raised to the x power. All right, so 5 and 25 are not the same number, but you can rewrite this as log base 5 of 5 squared. 5 squared is 25. X is already here. So now the log base 5 of 5 cancel, and this one would be 2x. Since A part deals only with numbers, you probably could type that one into your calculator as well. So let's see if we do 10 raised to the log of 4. And again, that's assumed to be base 10 when it's log and there's no base. Hit enter, and that gives you 4. Since this one has a variable, I'm not sure you can type that in, but hopefully you understand that the property that comes from the definition right over here where it shows that they undo each other, that should make sense. Example 6, finding inverse functions. Find the inverse of each function. So A part says f of x equals 6 to the x power. So we can use the definition of logarithm to simply rewrite this as the inverse. So we can say f inverse of x, that's our y value, and that's going to equal log. We can see that our base is 6 of x. So we are going to graph in the next problem, but it says find the inverse, and we've already talked about inverses being a reflection across the y equal x line. So let's use our calculator to graph both the function and the inverse and just kind of visually see how these two are inverses of each other. So if we go to y equals, the first one says 6 to the x power, so we're going to do 6 raised to the x power. And then the second equation is log base 6 of x. So I'm going to go to math and get my log base button and do 6 log base 6 of x. All right, now you will be able to use a change of base formula as well if you don't have this log base button, but this log base button should be on any updated calculator, and it makes it very nice. Remember, the y equals x is this dashed line, this invisible dashed line that goes through quadrants 1 and 3. And you could see if that dashed line were there, that these would be reflections of each other. So the red line, it looks like it starts right here. It actually goes on down as well, but it's going to ride that y-axis along there just like the blue line does on the x-axis here. So those are inverses of each other. B part, f of x equals ln x plus 3. So now we know that we are looking at our natural logarithm because we got ln, so we know that's assumed to be base e. And the first thing we need to do to find the inverse is to rewrite this as y equals ln x plus 3. Then we're going to switch our x and y, just like we did in previous lessons. To find the inverse, you're going to switch the x and y. All right, now we know this is base e here, okay? We don't have to have it, but we can write that there. And we know that we can do the same thing to each side of the equation, means it's still equal. So I'm going to write this in exponential form. So I'm going to write e to the x, and I'm going to write e ln e to y plus 3. And from the previous exercise, we know that the e and ln e, they undo each other. So those undo each other. So we're going to have e to the x power equals y plus 3. We're going to have e to the x, subtract 3 from both sides, and then that's going to give us our inverse. So we can rewrite this as f inverse of x equals e to the x minus 3. So this is the inverse function of ln x plus 3. All right, so you can see up here from the definition of ln of x equals log base e of y plus 3. In exponential form, this is written as e to the x equals y plus 3. So that's basically just stating to you, telling you why I did this right here, okay? Example 7, graphing a logarithmic function. Graph f of x equals log base 3 of x. All right, so you can see here, graphing logarithmic functions, this is the same key idea that we looked at a little bit earlier. Now we're going to look at what that means. All right, so we know that logarithms are inverses of exponential functions. So we know the inverse of f of x equals log base 3 of x is 3 to the x power. So we know the inverse is 3 to the x power. Now, as always, you can make a table of values, pick your x's, plug it in to find the y's, and that's how you would graph the exponential function, or just type it in your calculator. If you find a table of values for your exponential functions that gives you your x's and y's, if you want to graph a logarithm, find this table first, switch the x and y's, and that gives you your table of values for your logarithm. All right, again, I'm going to allow you to just look at these here. There's very few cases where you're ever going to need to do this without your calculator. So actually, I can't think of any cases that you're going to need to do this without your calculator when it comes to graphing. So let's graph both just to look at it. So we're going to graph the exponential function here. And again, if you wanted to sketch the graph, you simply do second graph, which is your table of values. Pick 3 or 4 values and put those points, and then you could sketch that graph. So let's go back to y equals and graph the logarithm function. So we're going to have math, and I'm going to go up to log base, and I'm going to do 3, and it's going to be to the x power, and hit graph, and that's going to graph f of x equals log base 3 of y. So this red function here is the graph of log base 3 of y. Now, let me show you one more thing before we're done. All right, let's say that you don't have this log base button. All right, so if you remember the change of base formula. The change of base formula allows you to change any base to like base 10, which means you could use this button here. So let's say we use our change of base formula, we're going to do log of x divided by log of 3. So we're going to do log of x, and then that's going to be divided by log of 3. And what that's going to do, that is going to make sure you have 2 parentheses here because you have 1 here and then you have 1 here. So you have to close both of those parentheses. So when you hit graph, it's going to graph the same thing as my calculator did when I used the change of base. When I used the other button here under the math log base button. So again, that is your change of base formula. You will see that change of base. I don't know if we've done this yet, but you will see it soon. Change of base goes from log base 3 of x. It takes it to log of x divided by log of 3. And that just uses your base 10. And that allows you to use your calculator to use this main button here if you don't have the other button. All right, that is all for this lesson. If you have any questions, let me know.